In this video, we will look at a program for Kruskal's algorithm. In the previous video, we saw the working of Kruskal's algorithm. It's very simple. Always select a minimum cost edge. That's it. So it's very simplest one. We will write a program for this one. For writing a program, I have taken an example graph here. This is there already in Prim's algorithm. I have used the same graph. Now, for writing a program, two things are important: data structure and the operations. So first of all, decide the data structure. If your data structure is perfect and if you are able to work on it manually using pen and paper, then writing the program becomes damn easy. So I have a data structure here. Let us look at this. What are the data structures I have? See, I have taken array of edges. So if you remember in Prims, I have taken a adjacency matrix, that is cost matrix I have taken. But here I am not using adjacency matrix, but I am using list of edges. So let us see what are the contents. Already I have kept it filled. So this is an array of dimension 3 rows and 9 columns. Why 9? Because there are 9 edges. So if you look at the edges, first edge is 1 to 2, 1 to 2, and the cost is 25. 1 to 2, cost is 25, right? So first row is containing first vertex number, then second vertex number, and the last row, that is 2, index 2, is containing their cost. If you look at next 1 comma 6, next edge, from 1 there is an edge to 6, its value is 5, 1 6, its value is 5. Then let us take a vertex 2, 2 to 3 12, 2 to 7 10, 2 to 3 12, 2 to 7 10. Likewise, it is already filled. Then you already know the working of the algorithm. Always find the minimum edge. From this I have to select minimum. It's not a big task. Take out the minimum and include it in the solution. The next minimum include in the solution. But the edges that I have already included, I should not include them again, right? So for that, how to know whether it is included or not included? When we are selecting anyone, you should know that they are not included. So for that, I have an array of size 9, 0 to 8, to mark them included or not included. So from here, whichever edge I am selecting, I'll mark this as 1 there to show that this is included. If it is 0, it is not included. So this array will maintain the record of the edges so far included in the solution. Then for getting the solution also, I need a data structure. So that is, I will take a data structure here, that is T, which we have already used this in Prim's algorithm. So how many edges we will be getting? 6 edges. So 0, 1, 2, 3, 4, 5. So this is 0 to 6, 5, that is total 6 edges. So I'll be storing the result there in that data structure. Whenever you are picking up a minimum edge, you have to make sure that inclusion of that edge is not forming a cycle. How to detect a cycle? Yes, for detecting a cycle, we will use set operations that are union and find. So for that, I have an array called set, and I need, there are 7 vertices, right? 1 to 7. So 1 to 7 I have taken. So starting from 0, I'm not using this one. So I put a cross mark there. I'm not using it. I'll be using it from here. And all these are filled with -1 initially. Now how set and union, that is set operation union and find works, I will show you while tracing this one. So I will trace this Kruskal's algorithm, the procedure which we have already seen, by using this data structure, how they will work in this data structure. Then afterwards, I will write on a program. What all I am doing here, for that same thing, I will write a program. So let us see the tracing of Kruskal's algorithm upon this data structure, because we have this graph in this form now, in this form. This is on paper, this is inside memory. So let us see the working. For tracing Kruskal's algorithm, we already know that Kruskal doesn't have any initial steps. Everything is repeating step. And for knowing whether there is a cycle or not, we use sets, and already you have learned what is union and find, and weighted union and collapsing find, both we have seen. So let us follow the same thing here. We will use that one to check whether there is a cycle or not. Let us start the procedure. What is the procedure? Find out a minimum cost edge. Find out a minimum cost edge. So from this, we will trace this and find out minimum. So first minimum is 5. So let us call this as J. Let us call it as J, right? And here, is it included? No, it's not included. So now this is minimum. So find out whether it is forming a cycle or not. So for 1 and 6, check who is the parent. If their parent is same, they belong to same set, means they will form a cycle. This is the method. So let us check. Find 1 minus 1. Find 6 minus 6 minus 1. So they are parents of themselves, right? So if I draw it here, this is 1 and this is 6. So they are not forming a cycle. Their parents are different. One's parent is 1 and 6 parent is 6. They are not forming a cycle. So we can include this one. Let us include this in the solution. So let us put I here for filling this one. This is 1 and 6. And here at 1, because it is included, mark it as 1. This one we have included, mark it as 1. So this is over. Now perform union upon them. Weighted union on 1 comma 6. So as we have already learned weighted union, we will check. This is minus 1. That is also minus 1. Who is minimum? 1 is not smaller. So make 6 as a parent. So here I will write 6. And now there are total 2 vertices here. So this will be minus 2. So this comes under this one. 1 comes under this. And this will be pointing on this one. This is just like this. 1 says that my parent is 6. And 6 says that I am the parent of myself. I am the parent of a set. And I have 2 vertices, minus 2. That's all. Step is over. Now let us do it repeatedly. Find the minimum. Next minimum. Who is the next minimum? Out of all these, this 8 is minimum. So this one. See, it is not included, right? 4 is not included. So that's how this is taken. And this is marked as 1. Now whether to include 3 and 4 or not. Find 3 and find 4. Find 3. 3 is a parent of itself. Find 4. 4 is a parent of itself, right? These are 2 different. So there is no cycle. It will not form a cycle. Then 3 or 4, which is a smaller? Both are equal only. So we'll update this one and make that as parent. So we will write 4 here and this we will write as minus 2. This means that 3 says that my parent is 4, right? And 4 says that I am the leader of this set or head of this set, and there are 2 vertices in this set. That is 3 and 4. And this 3 and 4 are included here. 3 and 4 are included. So you perform union also, weighted union also, we have included this one. That's all. So same thing will repeat. Again, find out minimum. Which is minimum out of all these, which is not yet included. Don't include 1 and 4. Means don't take this 5 and 8. Other than this, this is next minimum. So this is J. 10 is J. Find 2 and 7. Find 2. Find 2 minus 1. Find 7 minus 1. So this means that this is 7 and this is 2. I will write like this. They are independent now. Then it means it's not forming a cycle. So you can include this one, 2 comma 7. 2 and 7 are included here. And this one, 3, is made as 1. It means it is included. Now we have to perform union. So 2 and 7 both are minus 1 minus 1. So this 2 will be pointing on 7. And here I will write 7. Now 7 says that there are 2 vertices under this set. 2. So we got 3 different sets now. Now again repeat. Same. Again the step is repeated. Find out minimum out of all these. Right? After 10, the next minimum is 12, this one. So this is J. Is it included? 2, is it included? No, not included. Then find 2 and find 3 to find out whether they are forming a cycle. Find 2. 2. Who is the parent of 2? 7. Find 3. Who is the parent of 3? That is 4. So yes, they are different. So we can join them. It is not forming a cycle. So who is smaller? 4 or 7? Both are equal only. So what we do here is at this place we will write 7. Now this says that there are total 4 vertices under this one. So this 4 comes under this. So I will draw it once again here. 4 and under that we have 3 and this is included here. So they are forming a single set. And at this 2, mark it as 1 to show that this is already included. And 2 comma 3, you write it here. This is included in the solution. 2 comma 3 is included. Now repeat the steps. Find out the minimum one. After 12, 14 is the next minimum. And find 4, find 7. Find 4, find 7. Find 4, parent is 7. Find 7, parent is 7. See, here if you check, find 4, 7. Find 7, 7. So both are same, 7, 7. Parent is same. 4 is under this 7 only. So this will form a cycle. Don't include this one. But this vertex, this edge, we cannot include it. That is sixth one. Mark it as 1. Next time, don't consider that one. It's not included in the solution, but this is over. This is finished. So just mark it as 1. So that's how we found a cycle, that there is a cycle when both their parents are same. For 4 also we got 7, for 7 also we got 7. Now next step, find out the next minimum, right? After 14, the next minimum is 16. This we get 4, 5. Whether 4, 5 can be included or not. Find 4. For find 4, 7, 7. 7 is the parent. In the diagram you can see. Find 5. 5 is not yet included. 5 is independent. 5 is independent, right? 5 is the parent of itself. So yes, this is not forming a cycle. So when it is not forming a cycle, include this 5. Make it as 1 here. Then this is 4, 5. 4, 5. Then we have to perform union. So 5 should go under this 7 because this is the parent of this one. And how many are there? -4 and this is -1. So here we write 7 and now this is having -5. 5 vertices are there. 1, 2, 3, 4, 5. So now next, check the next one. Find the next minimum. This is over. After 16, the next minimum is 5, 7. This one. That is minimum. Find 5 and 5, 7. Find 5. Who is the parent? 7. Find 7. Who is the parent? 7 only because this is negative. So both are giving same. So this 5 and 7, they belong to single set. This will form a cycle. If they are belonging to same set, it is forming a cycle. So don't include this one. So don't include in the solution, but mark it as 1 to show that this is finished. Right? This is completed. Included. This edge is gone. Deleted now. Okay. Then next, find the next minimum. After 18, the next minimum is 20. 5, 6. 5, 6. Find 5, 7. Find 6, 6 itself is a parent. So find 5, 7, find 6, 6 only. These are different sets, so they are not forming a cycle. So just include this one. So this is 5, 6 included in the solution, 5, 6, and mark this as 1. This as 1. So seventh one is 1. This is included. Now that's all. See, actually we have finished all 6. We got all 6. That's all. We can stop here because we got n-1 edges and we got the solution. So this is the working. So in between the set is also there. So if you have already learned about sets or if you have not seen this, I just suggest you go back and check it. This was there. Otherwise, it's very simple. Take minimum included, take minimum included. But forming a cycle or not, that's what we have to detect. And sets helped us. For sets, we will use collapsing, find and weighted union. So now I will write on the Kruskal's program, right? I will prepare this data structures and also I will write on the instruction. Let us look at a program. So already I have written piece of code for a program. Let us understand what is there. See, I have not yet started main function. I have just taken these data structures, this edge and set and include and t. So how I have declared, I will show you. See, this is maybe we want minimum, so we want some value that is infinity. For we have to find out minimum. So that's what I have written, the largest number there, I. This already I have shown you in Prim's algorithm. Now this is edges, a two-dimensional array, 3 rows and 9 columns. So first row contain first vertex and then second vertex and the cost of an edge. So this is forming one single edge, right? So I have taken it is row wise. So first row, first vertex number, second vertex number and the cost of edges. This is first data structure, this one. The next is sets. All are initialized with -1. For implementing sets, for checking cycle is formed or not. So initially, if you remember, this was -1, all were -1. All I have filled up with -1 and the size is 8. That is 0 to 7. So we will be using from 1 to 7. First one we will not be using it. Then whether to find whether this set should be considered or not considered, means deleted or not deleted, included or not included, we have an array that is included. If you remember, this was initialized with 0, then later on when I was including them, I was marking them as 1. So whether these edges are included or not, for that we need an array of size 9 because there are total 9 edges. And if you just write 0 here, everything will be initialized with 0. You don't have to put 0 9 times. Now next thing is a two-dimensional array with 2 rows and 6 columns for a solution that is spanning tree. I have this one. Now this is weighted union. Already we have discussed this one, right? So I will not explain this. This is a weighted union, and similarly collapsing find method also, function also we can write down. I have written just union. Find I don't have to show you, alright? Already there is a topic on this one. Now let us write down the main function for Kruskal's algorithm. The procedure is very simple. I will write on the code and I will explain you. Here I have written a main function for Kruskal's algorithm. Look at this one. See, these are the variables that I will be using. I for this preparing a tree solution, I was using here. That is starting with 0. And as we are including the edge, I will be increasing. Then j, k, n is number of vertices, e is the number of edges. Minimum, for finding a minimum we need some variable, u and v for any edge, whichever edge, like 1, 6. So 1 is u and 6 is v. So for that I have declared the variables. Now if you look at the code, this is a simple loop. Everything is repeating. So just a simple loop. This while loop. For I assign is already 0, right? I is less than n minus 1 because we need n minus 1 edges. So this loop will repeat for n minus 1 times. That's it. And what it will do every time? Find out minimum edge. Out of all these edges, whichever value is minimum, and that value should not be included. Means it should not be 1, it should be 0. So that included should be 0 and that edge is minimum. If it is minimum, this for loop is finding out, this for loop is finding out minimum 1. If you got any minimum, change minimum, record it as k. See, suppose this is minimum, first one is minimum, we are taking it as k, mark it as k. While explaining I was saying j, okay, j I was using. Now here in the code I am using k here, mark it as k. J is used for scanning, but whichever is minimum there k will be pointing. And also I am taking the edges u and v. Whichever is minimum, like suppose I have got the answer k as 1, then this is u, this is v, u and v, those two also I am taking. So this is portion, this for loop is for finding minimum. Just observe this one. What I have explained you, same thing is written here. So once you got u and v, check, find out that there when you perform find, they should not be same. Result of find means their parent should not be same. If parent is same means it's forming a cycle. So if the find of u and v is not equal, means it's not forming a cycle, include this in the solution, u and v. So u and v inside t. This is t of 0, I and t of 1, I. Because I have used there. So at that place write on u, v. And perform union on u and v. That is, who are u and who are v here? This 1 and 6 are u and v. Perform union on this 1 and 6. So in this set. So whatever the find has given the result, upon them we have to perform union. Okay, not directly union of u, v. Find result, whatever the parent, whoever is parent, join their parents. So union of find of u and find of v. Then as we got an edge, increment I. Move to the next free space in this t. That's all. And also make this include of k, whichever edge we got, make that as 1. Mark it as 1. That edge as 1. Here we have to mark it as 1. Alright, whether it is included or not included, that was the minimum. We have finished with this edge, just mark it as 1. So this is outside if, not inside if, right? Whether include or not include. If it is forming a cycle, we will not include it. But we will not include in the solution, but we will mark it as 1 to show that this we are not going to consider again. That's all. This is repeating every time. And at the end, print the result. So this is the simplest algorithm. The coding is very simple. The main function is very small. I will code this and I will show you. I will write down the program code and show you. So you can watch the next video for demo.